All right, welcome back for another AP Computer Science lesson. This week we're going to be jumping into one of the most important topics in the course, which is the idea of classes, class design, and objects. This is really the core of what we call object-oriented programming, or OOP, and it's one of the things that made Java such a successful programming language. So in order to talk about this, we're going to start with the structure of a class, what we call a constructor class. And then we're going to talk a little bit about how we instantiate or create objects of that class and what that means. So you'll see in the code behind me that I just have some commented out. This class is called student. So we're going to use a person, or in this case, a more specific person, a student, and we're going to come up with some ideas of what attributes they might have, and then how would we construct this student person. So what I like to do is I like you to imagine that you've just enrolled in school. So maybe you've just enrolled at university and you have gone online and you've created an account and submitted an application. And when you do that, they are going to create a student profile for you in their student information system, also known as an SIS. We have one here in high school too. It's where we store all your grades and your attendance and all of that stuff. And when you registered for school and grade primary, a profile was created for you. And there was a class for a student. And that class started to fill out certain attributes. When your parents fill out that form, or when you fill out that form online for university, those attributes get put in there. And there might be attributes for your name, your age, your date of birth, your social insurance number, etc. Kind of demographic information. And then there might be attributes for things like, has paid his application fee, or have you submitted an application, or what program of study were you interested in applying for? They might have hidden attributes that you don't see for things like your grades that they pull off of your transcript. What category does your grade range fit into? And they might have their own system for that. So we're going to use that as a basis for teaching objects and classes. So we're going to start with the top, and you'll notice I've entered my class. Now, before you enter your class, if there's anything you need to import, you would do that up there or declare the package that you're in. So you'll notice the first thing I have listed is something called field variables, or class variables. These are variables that we want to be able to be accessed at any part of our class. So within methods, within constructors, we should be able to access any variables that we list up here. So this is a great spot for us to list things like demographic information. So for example, we might have a private int age. Now we can put more than one because we're not initializing them. We're just going to establish them. So let's say, for the sake of this, we are talking about university. So we're probably not going to put grade. So we're going to put probably age, other integers that we might want. Date of birth we're probably going to take in as a string as opposed to as an integer. So maybe the only one we want is age for now. We're going to want some strings, private string. We're going to want something like first name, maybe middle name, last name. We might want a string for date of birth. We might want a string for address. Okay, let's just stick with those ones for right now. So you start to see, and these have been named, so they've been declared, and their type has been stated. So an integer called age, a string called first name, a string called middle name, and so on. So that's called declaring variables. Now these variables currently have no value. So integers get automatically set to 0 if we don't initialize them. Strings will automatically get set to null if we don't initialize them. So they exist, they just, they haven't been initialized. So we're going to add two more variables. I'm going to add an integer called myID, and I'm going to add another one. Now this one I'm going to talk about a little bit, but it's private static int, and this is ID tracker. And I'm going to give this a value of 2020-001. So we're going to talk a little bit about what this declaration of static means once we start looking at creating objects of this class. But essentially, this is going to be a tracker variable that's going to increment every time a new person gets created. Because if you imagine registering for an online university or registering for university online, well, you might be registering here in Wolfville at the exact same time as somebody in Halifax is registering. And yet the information system needs to be able to assign you a different student ID than it assigns them. So as soon as you click submit on your application, it assigns you a value. Something in the background needs to track that ID has now been taken so that the next person who comes in doesn't get the same student ID as you. So we need to have this background tracker variable. And the thing that's going to be cool about this is it's kind of like an umbrella in that if you imagine the very peak of the umbrella and then all the spokes that go down to the bottom, the individual students are down at the bottom of the umbrella. They can't see each other. They don't know each other's student IDs. They don't know each other's date of births or last names. But up at the very top, if you have a static variable, that static variable is visible to all of the spokes of the umbrella. Okay? So down at the bottom, everyone can look up to the top of the umbrella and see a static variable. So this ID tracker number, when anybody creates a new spoke on this umbrella, they can look up and be like, oh, the ID tracker is at that. Okay, I'm going to grab that and I'm going to iterate it to the next number so the next person has a new number to grab. So let's jump into constructors. So what is a constructor? Well, when we're talking about a constructor class, which is what this is, a class that contains constructors, we're talking about a class that we're going to want to have multiple copies of, but each of those copies might have its own unique information. So for example, you're going to need more than one student, but each student is going to have their own names, their own date of birth, their own ID, their own age. So they need to be unique, but then they also still need to follow the same framework. So they all need to be students. We call this creating an object of a class or instantiating a class. And so the constructor provides the framework or the parameters for how do we handle the case where somebody wants to make an object of this class. Is there anything that we need to do on our end in order for them to be successfully able to work with this object of student that they're creating? So the syntax is very simple. The syntax is just like the class, but without the word class. So public student. Now this is what we call a blank constructor, also known as a no arguments or a no args constructor. And what we mean by that is if you look in the brackets, there is no parameters given. So someone can create a blank student effectively. So remember, in a blank student, first name, middle name, last name, date of birth, address, age are not going to be defined. They're all going to be null or zero, okay? Because we don't have that information, which is okay. We can still create the framework for the student and then fill in that information later, but we can't fake it with the ID because we need to pull that tracker and we need to increment it as soon as a student gets created so that we don't end up with duplicate IDs. And this is pretty straightforward. We're going to take my ID, that is mine. I'm at the bottom of the umbrella spoke. Nobody else knows that variable because it's not static. And I'm going to assign it the value of ID tracker. So I'm going to look up to the top of the umbrella. I'm going to grab that static variable and I'm going to copy it into my own variable. And then I'm going to iterate ID tracker so that the next person who looks at ID tracker is going to see the next number in the sequence. They'll see 2020-002. And as each object gets created, because remember the objects are never actually created at the same time. In computing, it's always a stack. Okay, they're not happening at the same time. So it's happening one operation at a time. Even though it might feel like you both clicked the button at the same time, one of them goes to the queue first. It's like if two people hit print on a printer at the same time, one of the pieces of paper is coming out first. There's conflict resolution there. So one of them is going to happen first. The ID tracker is going to iterate. The next person is going to get the next ID. This is all that we need the blank student to do. So we can create multiple constructors. We can create a constructor that takes 2 arguments, 5 arguments, all the arguments. We can have 20 constructors if we want to. The way they're going to be distinguished is based on the parameters that people provide. So if someone only provides no parameters, it's going to call the blank. If somebody provides all the parameters, it's going to call the one with all of the arguments. So that's what we're going to do. Now, do not use the same variable names as your field variables. Those are whole class-wide variables. This is just a teeny little local variable that I'm going to use to pull the information as a parameter from the person who's creating the object. So I'm just going to use really short names like int a for age, string fn for first name. I'm using semicolon instead of commas because that's the kind of day it is. And try that again. Middle name, string last name, string dob, string add, and that's it. So now we enter into the constructor. And all we're going to do, really simple. Now, once we learn if and else statements, we learn that we can add, conditions in here. So we can say like if the age variable is, under 17, then throw some kind of an error or do something. If they didn't enter a properly formatted date of birth using substrings, we can look at that. But for right now, we're just going to say, bam, we trust them. They're going to give us all the right information, so let's fill it in. So age, which is my local variable, is going to be equal to the a value that they've given us when they created the object. First name is now fn. Middle name is now mn. Last name is now ln. Date of birth is now dob. And address is now. So all I've done here, I've taken all of my class or my field variables and I've assigned them the value that was given when they created the object of my class. And then I still need to do this. Still need to increment my ID. Because again, this and this are never going to get called at the same time. They're either creating the student without information or they're creating the student with information. Okay? Now, you'll notice the word private. What does the word private mean? Well, what the word private means is that any file or anybody outside of this class who creates an object of student cannot directly access private. Okay? So what this means is that the only way for them to access private is to ask for it. So if they want to know your age, they need to ask for the age. If they want to know your name, they need to ask for your name. And we provide methods as that means of asking, or a call and response. Okay, because we don't want them to just be able to go in and directly hack the balance or the ID or the age. It would be the equivalent to you going to an ATM, putting your card in and just typing balance equals 1 million, hitting enter, and bam, your balance is $1 million. Well, no, we don't want that. Instead, you have to say withdraw. And when you say withdraw, it's a method and it's going to check how much money you have to withdraw. And it's going to have decision-making code as to whether or not you can. So we don't want direct access to variables. We want to control it with methods. So these are called accessor and mutator. Accessor methods allow you to access the value in a class variable. Mutator methods allow you to potentially change the value. So they look something like this. An accessor method is going to return a value. So public means that you can see and access this method. Int means it's going to return back an integer, so call and response. The person calls and says, can I get your age? And you respond with a number, get age. And it's a common practice for you to use the get and set prefix for accessor and mutator. So this is going to say if they use the get age method, they need to be ready to handle that you're going to throw an integer at them. And all you're going to do is return age. So when they call this method, they need to be ready to receive an integer. Just like when we do a scanner.nextInt, we're ready to receive an integer. We're going to store that somewhere. So we're going to return age. We're going to repeat this process for each of our variables. Public string get first name. Return first name. Public string get middle name. Return middle name. We'll also put a get ID, which returns my ID, not the static, my ID that I own. Okay, so I've added in all of the get methods, which are the accessor methods. So anybody who creates an object of student can call, dot get age, dot get first name, dot get middle name, and it will return that value and they'll be ready to handle it. So mutator methods are much the same, except they're going to be void. So we don't need to return anything to them. We just need to modify something internally with this object. So public void set age, we need to ask them for an integer. So we say when they call set age, they need to give us a number that they want the age set to. And then we're going to assign the number they gave us to our field variable. But we're not going to give them anything back. We're just going to make the change on the back end. You'll notice I'm using the same abbreviated variable names that I use in the constructor. That's okay. Those were local in the constructor. They got erased from memory as soon as the constructor finished running. So there's not going to be any conflict there. Now the class and field variables are consistent through the entire thing. Now I'm going to stop there because I don't want to give them a mutator method for the ID. The ID has been set. They don't have control over changing that ID because that could create a conflict with another student because they don't see each other's IDs. So we don't want to put that in there. So that's all I'm going to do for my getters and my setters, or my accessors and my mutators. So next up, we're going to do something called the toString method. And what this is when you try to print an object, you know what? Pause. We're not going to do that yet. We're going to come back and do that in a minute. So we're going to jump over to another Java file. Now, important note, these two Java files need to be in the same folder. So you'll notice what folder am I in? Chapter 4 video. Here we go. You'll notice my apcsa.java and my student.java are in the same folder or the same package as well. That's important. So this is going to be my main or my running class. So this is not going to be a constructor class. It's not going to have a constructor in it. We're going to use this to create objects. So let's create a student. So I'm going to jump right into my main method. And I'm going to do student. So that's my variable type. It is a student variable. Bob equals new student. So same notation I would use to create a new string or any class-based variable. Class name with a capital matches the Java file name. Variable name, this is my name. I'll use this in this class, or in this method, sorry. It is a new object. This is important. This is a reserved Java terminology for creating a new object. And it is a student. Notice, no arguments given. So which constructor is it going to call? It's going to call the blank constructor. So really it'll set the ID, but not really much else, right? So we're going to try a couple things. We're going to print out Bob's ID. So bob.getID. Okay, because I want to see what his student ID is. We should know what it is, but I want to see it. And then I'm just going to try this. .out.println Bob. So Java has a way to print objects. It uses something called the toString method. And there is a toString method that already exists in Java that automatically gets called anytime that you run a print on an object. So let's run this. So we see there is the ID and it's right. And then it just prints this gibberish, which is essentially, look at this, this is hex. It's a memory location. It's a memory location for where the object is stored. Well, that's cool. It's not at all useful. What we can do though is we can override the existing toString method with our own. So we can do public string toString, and we can write a method of what we want it to return. Right? So we could return something like, or we could, there's a bunch of ways to do this, but we could return, a string that has a bunch of information like ID plus my ID. So now if I run this code, you'll see instead of printing the memory location, it prints that string that I returned in my toString method. Now we can make this more elaborate and we can have it include all of the stuff. So ID, maybe then we do a quotes and a \n, which jumps to a new line. And then we do name plus first name plus space plus middle name plus space plus last name, right? And then maybe plus, and we go to a new line again, \n. And now we're ready for maybe the date of birth. DOB plus date of birth. Okay, plus maybe we want to throw a tab in there. And then the next one, so we put a \t, then we put address plus address as a variable. Plus, and let's go again. New line. What's left? We got their full name, their date of birth, their address, their ID. I think we got everything. So maybe we don't need any more after that. We just end it with a new line so that we know that the next thing that gets printed is going to be there. So let's run that. So now it prints ID, name is null, 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 date of birth is null, address is null. Cool. That's okay. Let's take our student that we created. His name was Bob, right? So let's add in some setter methods. Bob.setAge. Oh, we didn't put age in our print. Let's go do that. That's what we forgot. We got the name. Let's add in the age here before we go any further. \t age plus age plus. Nope, I don't need a plus there. Yeah, that should do it. Okay. So we're gonna add a set age. We'll make Bob 18. We'll do Bob.set first name. Notice how they show up in Eclipse. Isn't that lovely? And we're gonna call him Bob. Notice I put it in quotes because it's a string. It's expecting Bob G. Doe. Okay, let's set him a date of birth. Now remember, we have no restrictions on what I enter here. So even though I'm going to enter a properly formatted date of birth, it doesn't expect or demand that. Okay? So I enter a full address. So now I have age, first name, middle name, last name, date of birth, and address. And now I'll ditch this one and we'll just print Bob. We run this. And now we have his ID, his name, his age, his date of birth, his address, and it's all there. We can access it and we can affect it. Now instead of doing this whole thing, we could also just print one of those things if we wanted to. .getDob, for example, and we could print just his date of birth if we wanted to access that one value. We could store those values in a variable and manipulate them in some way. So int x equals bob.getAge, system.out println in 10 years Bob will be plus age plus 10 plus years old. So we take the value, I guess that should be x, sorry. So we take the value from Bob, we use that value in our code, and then we run that through. So in 10 years, Bob will be 28 years old, and that shows up. So now let's go ahead and wipe that. Okay, so we can get access to the variable that way, and we can use it in our code. So we can also have multiple students, so we don't just have to have Bob. So let's do another student. Let's say Jane equals a new student. Now this time, we're gonna give all the parameters up front. So the order is really important. So if we pop over to student and we look at our order, it's age, first name, middle name, last name, then date of birth, then address. So we wanna make sure we put these in that order because we're not gonna be naming them. We're just gonna be hard coding in something like 14, Jane, comma, and then P, comma, and then Doe, and then we're gonna put in the date of birth. So, 12-09-84, and then we're gonna put in the address. So 111 Alphabet Lane, new minus, NS, B0K1H9. Maybe a space in there, and that should probably be in quotes. Nope, it shouldn't be. Right, and then we end with brackets and a semicolon. So student Jane is a new student, and we hard code all the information. Now 14 shouldn't be in quotes. Oops, because it's expecting an integer. Jane, P, Doe, date of birth, address, all separated by commas. So the neat thing here is if I print Jane using that toString method, without using any of the setters, notice she has a different ID, name, age, date of birth, address. So all that information is passed through because I used the full arguments constructor in order to do that. So no args and then use the mutator methods, or full arguments, and then we don't need to use the mutator methods unless we're changing something from when we initially created it. Okay, so play around with this code a little bit. Now you could create a field variable student as well, because remember, you can't access these students outside of that method. So if you tried to access them in roll call, it wouldn't work, or in class shuffle, or in any other method, it's not going to work because we created them locally inside of the method. So if we wanted to create one that we're going to use in the whole class, now this is a little different because of how I just described static, but we would have to make it a static student. So we could do something like this. Private static kid1 equals a new student. Now, oops, put those in the wrong order. Private static student kid1 is a new student. Now, the reason this one is static is not for the same reasons as the other one. Static still means that umbrella thing, but the issue is this is not a constructor class. So no one's ever going to create an object of my APCSA class. So the reason this one is static is to make sure that the main method call, which is a static method, can be called directly from outside of this code, can access this variable. Because a static method is not going to be able to access a non-static variable. So in the case that we want this to be accessible through the whole class, it needs to be static. Okay, it's not really the same as static in the context of a constructor class. So just keep that in mind. So if I wanted to access kid1 inside of my main method, it would need to be static. Now, the same goes for these methods. They're static because I might want to access them from the main method. So this is that initial idea of an object of a class, what a constructor class looks like, how we instantiate that object, how the constructors work, how the methods work, etc. So the idea for roll call was just for you to create a bunch of students, either create them or, declare them as variables, initialize them in your main method, and then call the roll call method to essentially print the information for all of those students. So you can do that manually using the toString method, or you can do that using a loop if you know how and you want to do it that way. Class shuffle is a neat one. What I want you to do with class shuffle is I want you, once you've created your students, so up here make up, say, 5 kids, fill them with information in the main method. And then what I want class shuffle to do is I want it to swap their last names, kind of one student after the next, right? So just with the 2 kids I have, Bob's last name, I guess they have the same last name, Doet. So in this case, the class shuffle would make Bob's last name Doet and would make Jane's last name Doe. And if you had 3, you would just kind of shuffle down and back up so that it would change their names by 1 and then reprint the roll call of all of their names or all of their information to the screen. So I want you to do that. I want you to play around with the roll call and the class shuffle. And then I also want you to add a accessor method and a mutator method. And I want you to add these ones. I want you to add a public string get full name. That's going to return the full name with spaces between them. And I want you to do the same mutator method. So the mutator method would be get full name. Set full name. That takes all 3 strings. First name, middle name, and sets the value of all of the names at once. So this allows you to kind of do it all in one shot instead of in multiple. So I want you to add those 2 in, and then I want you to play around with a roll call that prints all the students that you've created. You'll have to create them or declare them as fields or instance variables, and then give them values inside the main. You can also give them values up here. I should have mentioned that. You could do a full args constructor right here. You cannot do this outside of the method, but you can do this up here. You can do that, so that's okay. So play with roll call, play with class shuffle, add in the accessor mutator for the full name, and that should give you a good start on understanding this idea of objects, class structure, field variables, static variables, constructors, methods, all that stuff. That is really the core of everything we're going to do with code. So play around with these, recreate what I've done in this video, add a little bit onto it, and then you can have a look on the website of the classroom for the rest of the lesson and the homework that you'll do. All right, have a great week.